Angles in a semicircle is 90 degrees. What that means is, if I have a circle and a diameter, so that's the centre, wherever they meet, that will always be 90 degrees. So even if that was there, that would be 90 degrees, or here. So wherever the diameter meets, it's 90 degrees. How can we prove this? We always begin by drawing a radius line. So if that's the centre, that's a radius line. And therefore this is also a radius, and so is that. So I have two isosceles triangles, one here and one there. Now if I label this, because I'm trying to prove that this angle is 90, I will concentrate on these two parts. So if I label this x and this is y, this angle here has to be 180 take away y because it's a straight line. So 180 take away y. Now here x is equal to, if I have a triangle, the angles in a triangle add up to 180. So it's equal to 180 take away y and then divided by 2 because there's two of them and they're identical. Here if I label this z, again I have the same scenario. If I wanted to find z, that's going to equal 180 because angles in a triangle are 180. Take away this angle here, which we found to be 180 take away y, use brackets, and then we divide by 2 because there's two of them. I tidy them up, so if I tidy this up, I'll have 90 minus y by 2, and here I have 180 take away 180, then plus y divided by 2, which is y by 2. Now I'm trying to prove that this is 90 degrees, this angle here. So I add x and z, so x plus z is equal to 90 minus y by 2, that's the x bit, plus y by 2. These two cancel out, I'm left with 90, so we've proved it. X plus z is equal to 90 degrees. The next theorem says, angles at the centre is double the angle at the arc. So if I was to draw that, so that's your centre, and wherever they meet on the arc, this is always double the angle there. So how would we prove that? I begin by drawing a radius line. So if that's a radius, this is also a radius, and I have an isosceles triangle here. Again, I have another isosceles triangle here. I'm trying to prove that these two are half of this. So my concentration is going to be on finding these two angles, then adding them up. Now if I label this x and y, and if I label this a and b, this is also a, and that's also b, because isosceles triangle. If I was to find a is equal to 180 take away x and divide by 2. And then b is equal to 180, so angles in a triangle, take away y, divide by 2. I tidy them up, so that's 180 divided by 2, 90, take away x by 2, and this is again 90, take away y by 2. If I add them together, a plus b, that will be this plus this, so 90 minus x by 2 plus 90 minus y by 2, which will give me 180 minus x over 2 minus y over 2. Now this angle here, because this is part of angle around a point, that angle there will be equal to 360 take away x, take away y. So if I label this z, z is equal to 360 take away x, take away y. Now notice how z is double a plus b. So I'll write that down. Z is equal to 2a plus b, because a plus b is 180 minus x over 2 minus y over 2, and that's 360 minus x minus y. So we've proved it. We've proved that angles on the arc are half the angle at the centre, or the angles at the centre are double the angle at the arc. The next one. I have opposite angles in a cyclic quadrilateral add up to 180. What that means is, if I have a circle, and a cyclic quadrilateral is a quadrilateral inside the circle. So like this. I need to prove that the opposite angles add up to 180. My first step is always drawing a radius. So that's the centre, and a radius like that, and that. Now, if this is x, this has to be 2x, because angles at the centre are twice the angle at the arc. And if this is y, this has to be 2y. Now, these two, if I add them together, have to be 360 because they're angles around a point. So 360 is equal to 2x plus 2y. I can factorise out the 2, that leaves me x plus y. And if I take out 2 from here, that's 2 times 180 to give me 360 is equal to 2 into x plus y. I can divide both sides by 2. I'm left with 180 is equal to x plus y. So now I've proved that opposite angles in cyclic quadrilateral add up to 180. Okay. Angles in the same segment are equal. So that means if I have a circle and a chord, wherever they meet on the arc, that angle is always the same. So this angle will always be the same as this. And if I continue, it will be the same as that. Even if I had this scenario, so if they meet in the opposite direction or on the other arc, these all angles are the same. Now, how can we prove this? I begin by drawing a radius. If I label this x, this has to be 2x because angles at the centre are double the angle at the arc. If I label this y, then this has to be 2y because, again, same reason, angles at the centre are double the angle at the arc. Notice how 2x is equal to 2y. So 2x is equal to 2y, therefore x is equal to y. So we've proved it. Angles in the same segment are equal.